All right, so we're on questions 50 through 56. Which of these is an even function? Okay, so we have to remember, if it's an odd function, that means it's raised to an odd power. Okay, no even function can have an odd exponent. So that automatically cancels out to the third power, But then we also have to realize this x right here is actually raised to the first power, and 1 is an odd number. So we can't have a as well. So C would be my answer. Okay, if you're not sure, let's plug a value in. Let's plug in 2. So if I plug 2 in here, right, so that's 6 times 2 squared minus 8. 2 squared is 4, times 6 is 24, minus 8 is 16. All right, let's plug in negative 2. Okay, so if I plug in negative 2, well, negative 2 squared is still positive 4, which ends up being 24 minus 8, which is 16 again. So we just proved that it's even because our y values remain the same when my x values are opposite. Okay. 51. Which statement best describes how the graph of g equals negative 3x squared compares to the graph of f of x equals x squared? Okay. Well, transformations. Okay. So here's a transformation compared to that. The negative tells me a reflection, and the 3 tells me a vertical stretch by 3. Okay. So let's look at our options. Vertical stretch of f of x by a factor of 3. Okay, that is true. Let's keep looking. The graph of x, g of x is a reflection. That is true. Let's keep looking. This says a factor of 1/3. D says vertical stretch by a factor of 3 and a reflection, which are both the ones that we want. So D would be my option. 52. A flying disc is thrown into the air from a height of 25 feet at time 0. Okay. The function is modeled by the situation h of t equals negative 16t squared plus 75t plus 25. T is seconds and h is height. Which of the values of t best describes the time when the disk is flying in the air? So here we go. So at 25 feet, it's flown and it flies and then it finally hits the ground. Okay. So we want to know which what talks about this distance. Okay. So when t is 0, until what point? Well, this point is when y is 0, right? It's touching the ground. So when y is 0. So remember, this is just y. So y equals negative 16t squared plus 75t plus 25. And wants to know when y is 0. Anytime it's asking for when something touches the ground, you're plugging in 0 for y. And when I have an equation or a quadratic function set equal to 0, that tells me, hey, let's solve. Okay, so one way we can do it is we can find this vertex. Remember, the vertex is smack dab in the middle. Okay, or we can use quadratic formula. Either one is fine. Okay, I'm going to find the vertex because it's a little simpler. So start by finding the vertex, negative b divided by 2a. So negative 75 divided by 2 times negative 16. So here we go. Oops. Negative 75 times 2 times negative 16 gives me 75 over 32. Okay, which is about 2.3. Okay, so this distance is 2.3, but remember it doubles because we want to know how long it takes to hit the ground. So another 2.3, which would be 4.6, which would be closest to 5. All right, 53. A certain population of bacteria has an average growth rate of 2%. The formula for the growth of the bacteria's population is A equals P sub 0 times 1.02 to the T. Okay, P sub 0 is the original population. So if we begin with 200 bacteria, so that right there tells me I'm beginning my original, so that's P sub 0. How many will there be after 100 hours? Well, that's T. So let's use our formula that they've provided me. And let's plug in for P sub 0 and T. 100 for T. And then let's use our calculators. So 200 times 1.02 raised to the 100. And that gives me 1,448. So that would be C. All right, number 54. All right, what is the average rate of change over f of x over the interval -2 to 0? I see a lot of information. I see, well, average rate of change I know is just my slope. And I know to find slope, I'm going to find the distance, the difference between 2 points, okay? So my points are going to be -2 to 0. So let's create those coordinates. And then let's remember x1, y1, x2, y2, and let's apply these to this, okay? So y2, 5 minus y1, 15 over x2, 0 minus x1, -2. Well, that gives me -10 over 2, which is -5, so B. All right, what is the end behavior? Okay, end behavior. So I want to know, what do the ends of this graph look like? Well, I see that number one, it's a quadratic. And I also see that this negative tells me it opens down. Okay, so this quadratic looks like this. Okay, so if it opens down, both my ends are pointing down. They're going to -infinity. Okay, so they're both decreasing. So given that, B would be my option, because in both times, as x goes to the right and as x goes to the left, so as x increases and as x decreases, right? As x increases, this goes down, and as x decreases, this goes down. And then 56, the points 0, 1, 1, 5, 2, 25, and 3, 1, 25 are on a graph of a function. Which equation represents the function, okay? So I can kind of rewrite these points to be a table if it helps me. So 0, 1, 2, 3, 0 is 1, 1 is 5, 2 is 25, and 3 is 125. And then I can see a pattern, right? I can see that to get from 1 to 5, I'm multiplying by 5, and that pattern continues. Okay, so if I'm multiplying, this is an exponential equation, okay, which would lead me to believe that d, 5 to the x, would be my, my function.